Section 3.1, functions. Section 3.1 starts with two vocabulary terms. The first one is relation. A relation is a pairing of inputs with outputs, and I'll show you what that looks like here shortly. And then the second one is a function. Now, a function is a specific type of relation that pairs each input with exactly one output. Okay, so basically another way of saying that is that x, or your input, and maybe I'll replace x, because usually input is x, but your input does not, underline not, repeat. Okay, the input does not repeat in a function. Okay, so the first couple of examples in this section say, determine if the relation is a function. All we need to look at is if the inputs, in this case the x values, we need to see if any of those repeat. And if you look, -2, -1, 0, 1, 2, I didn't say the same number twice. Now, if you notice, there are the same y values. We got 3 2's and we got 2 0's, but the definition of function says the input does not repeat. I don't say anything about the output. The outputs can repeat. Okay, it's okay even if all 5 of these y values were 2's, it would still be a function as long as none of those x values repeat. So number one, this is a function. Okay, it's a function. None of the x values repeat. Number two, we got 4 0, 8 7, 6 4, 4 3, and 5 2. Well, if you notice, we have the input, or the x value of 4 repeating, and it goes to a different y value. So, or a y value is usually your output. Okay, so number 2 is not a function because we have that x value of 4 repeating. Okay, if it didn't repeat, then it would be a function. But since we have this y value, or this x value repeating, it is not a function. Number 3, this is a different way of writing. Instead of ordered pairs, you can display your relation in a table. But again, if you look, we have the x value of 0 repeating, and it goes to different y values. Okay, so because of this part right here, this is not a function. Not a function because that repeats. Okay, we have the x value of 0 repeating, so it makes it not a function. And then lastly, number 4, this is what's called an input-output table, or an input-output chart. Sometimes it's also called a mapping diagram. I'll just write that off to the side, a mapping diagram. You might see that on an assignment, create a mapping diagram. This is what a mapping diagram is. This is just another way of displaying a relation. We could rewrite this as ordered pairs. So we'd have -1, 4, we would have 3, 15, and we would have 11, 15. So the question becomes, is this a function? Well, if you look at your x values, 1, -1, 3, 11, none of them repeat. So number 4 here, this one is a function. Mapping diagrams, I think, are the easiest to see whether or not it is a function. As long as there's only one arrow coming from each input, it is going to be a function. Now, let's say I had done this. Whoops, not that. Let's say I had done this, where now I have a second arrow coming from an input. This would make it not a function because we would have -1, 4 and -1, 15. We have an input repeating. They can all go to the same, let me get rid of that. They can all go to the same output. So let's see how these both go to 15. That's okay because there's only one output for each input. But as soon as you have a second arrow coming from the input side, from the same input, then it's no longer a function. Okay, so if you're given ordered pairs or a table or a mapping diagram, pretty basic to determine whether or not a relation is a function. Okay, so what if you're given something else, like a graph? Well, we need to use the vertical line test, and that's another vocabulary term. The vertical line test says a graph represents a function when no vertical line passes through more than one point on a graph. That might not make a lot of sense. Let me give you a picture to kind of better display what I'm talking about. So if we had a graph that looked, something like this, I'm just making it up. Okay? If I drew a vertical line, and I wish I could draw a vertical line on this, but if I could draw a vertical line, like there, or let me move it over to here, or let me move it over to here, or move it over to here. What you're noticing, and I'll just draw all those vertical lines back, there's no place where that vertical line crosses the graph more than once. Okay, and this one right here, this one's a function. Well, let me give you an example of what not a function looks like. So if we had another picture, and let's say our curve looked like this. Sideways U, kind of looked like a horseshoe. Well, if I draw a vertical line, I had crossed the graph twice. This one right here would be not a function. So if you can pass a vertical line over a graph and only cross that graph one time for each vertical line, it is a function. If you cross the graph more than once, then it's no longer a function. Okay, so use the vertical line test to determine if the graph represents a function. I'm going to draw a graph here, so this is number 1, and it's going to look like this. So we're going to have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We're going to have a point there. We're going to have a point here. We're going to have a point here. We'll have one here. Whoops. Down a little lower. One more over. And one up above. Is this a function? So that's the question. We need to use the vertical line test. So if I take a vertical line and run it through that point, I don't have more than one point on that vertical line. So far we're good. If I do the same thing with this one, I'm still good. I only got 1 point. But once I get into these points, what you notice is that they're on the same vertical line. So number 1, because we have 2 points on the same vertical line, and we actually have it twice, this one here, number 1, is not a function. Not a function. Okay? Let's try another one here, number 2. So number 2, we're going to have another XY plane. 1, 2, 3, 4, 1, 2, 3, 4. We'll have a point there. We'll have a point up here. And we're going to actually draw in a line. Okay, so if I take a vertical line across there, I'm good there. If I take one there, I'm good. There's good. There's good. There's good. There's good. We can put more vertical lines that we want. What I hope you're noticing is that no vertical line crosses the graph more than one time. Okay, so because we're only crossing the graph one time with each vertical line, this one is a function. And I hope you can see the difference using the vertical line test. If you cross the vertical line more than, or if you have the point on the graph more than once on one vertical line, it's not a function. If it only crosses one time, then it is a function. All right, moving on. A couple more vocabulary terms in the section, domain and range. Hopefully you've heard those two words before. The domain is the set of all inputs. The range is the set of all outputs. So a lot of times from here on out, especially in the rest of Algebra 1 and into Algebra 2, you're going to be asked to identify or state the domain and range of the graph. And that's what we're going to do here in problems 1 and 2. Okay, identify the domain and range of the graph. If you're given points, just points on a graph, like this one, like number 1, all you need to do is come up with a list. Okay, a domain. And really that's what we're going to do in both of these, but number 2 is going to be a little different. So the domain, well, it looks like this one has an x value of -2. This one looks like it's got an x value of -1. That one's at 0. This one is 1. And this one is 2. So our domain is going to be -2, -1, 0, 1, and 2. And it's not good enough to just write -2 through 2. That doesn't work. Okay, we actually have to list out all of the domains. Okay, all of the values in the domain. The range then, those are all the outputs, and the outputs are usually y's. Okay, so it looks like I've got, that'd be 4. That covers 2 of those. That would be 2, and that would be 0. It looks like we only have 3 different y values. So we're going to have 0, 2, and 4. Usually we write them in order from smallest to largest. Okay, so there's the domain and range for number 1. Number 2 is a little different because we have a connected graph. There would be no possible way to list out every point along this line. Because if we got really close to this line, what we would see, if we got close enough, would just be a big collection of dots. It would look like this with all the dots, but they're so close together that when you step away, they form a line. Okay, so we're actually going to use a compound inequality here to write our domain and range. Okay, so if we look at our domain, it looks like the farthest left we go is 1. That'd be the smallest, and the biggest kind of looks like 5. Okay, so this is, since it's a compound inequality and we want all of the numbers in between, we're going to write an and inequality. Okay, so remember and inequalities, we start with the largest, or the smallest number, I'm sorry. Start with the smallest number, The biggest number goes out to the right, and that'd be 5. Our variable goes in the middle. The domains in this case are x, and we need to come up with our inequality signs. We know they're both going to be less than, but we need to figure out if it's less than or if it's going to be less than or equal to. Since we've got dots here, closed circles, that means we do get to use those points, okay? Which means those 1 and 5s are allowed. So the domain here for number 2 is 1 less than or equal to x less than or equal to 5. What that tells me is that all the x values lie in between 1 and 5, including 1 and 5. For the range, range here, we're going to do the same thing. The highest is up here. The lowest is here. We're going to assume that's the 0, the x-axis. Okay? So the smallest is 0. The biggest is, let's see, that'd be 4. And we're not going to use x this time. We're going to use y because it's a different variable. We're talking y values now. And again, can we use 0? We're going to assume that that is 0. And obviously we can see that we're at 4. Okay, so we're going to have less than or equal to and less than or equal to. So the domain, or for the range, for the range for number 2, it's 0 less than or equal to y less than or equal to 4. Okay, so that says you can use all of the values, whoops, I wanted the pointer there. You can use all of the values in between 0 and 4, or all of the values between 0 and 4 are used in the range. Okay, 2 more vocabulary terms, independent variable and dependent variable. I'm going to underline them. Independent variable, dependent variable. Okay, the independent variable is the variable that represents the input values of a function. Independent, input. Okay, that's how you can kind of remember. The independent variable is the variable you get to choose, or the variable you control. It's up to you to determine what you do with that variable. Okay, usually the independent variable is x. Okay, in a normal x-y relationship. The independent variable is usually x. The dependent variable then obviously is probably going to be y. Now I've got an example here where we use y and x, but the next one, the last example, is not going to be x and y. So we'll need to figure out what it is that the independent and dependent variables are. And maybe you have to see it for independent and dependent variable. Independent variable is the one with control. The one you get to choose what happens, okay? And then this is the result. Okay? So, let's try an example here. The function y equals negative 3x plus 12 represents the amount y in ounces of juice left after taking x gulps. So number 1, what are the independent and dependent variables? So we're going to have 2 parts, 2 answers to this part. We need to identify the independent, and we need to define the dependent. Okay, so the independent. Do we get to choose, let's see, the x represents the number of gulps, y represents the amount of juice left. So do we determine how many gulps we take, or do we determine how many ounces are left? To me, that seems like we get to determine the amount of gulps, which is x. Okay, we get to choose how many times we drink from that cup of juice. The dependent variable then is the amount left, amount remaining. Amount remaining y. Okay, so we've identified the independent and dependent variables. Now, part 2. The domain is 0, 1, 2, 3, and 4. What is the range? So, the way we're going to do this, what I would recommend is making a table. Okay, we know the domain is x. We know the range is going to be y, because that's the independent and dependent variables. I'm going to make a table. I'm going to fill in our domain. 0, 1, 2, 3, and 4. Okay, so the question then becomes, how do I find those y values? How do I find the outputs, or the range? Okay, how you do that is what I call plug and chug. Okay, plug and chug to find those y values. We're going to take these x values, 0, 1, 2, 3, and 4, and we're going to put them back into our equation, or our function right there, negative 3x plus 12. Okay, so I'm going to rewrite that function just so I don't have to scroll back and forth. Y equals negative 3x plus 12. Okay, so I'm going to take these x values, and I'm going to plug them in for our x, and we're going to find y. So let's start with 0. So y equals negative 3 times 0 plus 12. Negative 3 times 0 is 0, and then 0 plus 12 gives me 12. So my y value is 12 when x is 0. Okay, we're going to do the same thing with 1. Y equals negative 3 times 1 plus 12. Let's scroll up a little farther. Negative 3 times 1 is negative 3 plus 12. Negative 3 plus 12 is 9. So then under 1, we're going to have 9. Keep going. Do the same thing. Y equals negative 3 times 2 plus 12. Negative 3 times 2 is negative 6 plus 12. That would be 6. So 6 goes under 2. We're going to have y equals negative 3 times 3 plus 12. Negative 3 times 3 is negative 9 plus 12. That is 3. And we got one more to do here. Y equals negative 3 times 4 plus 12. Negative 3 times 4 is negative 12 plus 12. Anything, those two are opposites. If you add opposites together, you get 0. So 0 goes right there. So we haven't exactly answered the question yet, but we've kind of filled in a vast majority. We just need to formally write our answer. Okay, so the range, if the x values are our domain, then the y values are the range. We'll write them in order from least to greatest: 0, 3, 6, 9, and 12. This would be your official answer for number 2. There's kind of, I don't want to say a lot of work, but it's a little bit of work to come up with a formal answer for what is the range. Let's try another one. I said I'd give you one that didn't have x and y. So the function a equals negative 4b plus 14 represents the amount A of avocados left after making b batches of guacamole. Okay, so number 1, what are the independent and dependent variables? Let's start there. Independent and dependent. What are you choosing to do? Are you choosing to make batches of guacamole, or are you choosing the amount of avocados left? To me, we're choosing how many batches we're going to make, because the amount of avocados left is a result of making the batches of guacamole. So to me, the independent variable is the number of batches, and that is b. Whoops, that's a terrible b. B. The dependent variable then is the amount left, or the amount remaining, and that is a. Okay, so number 2, the domain is 0, 1, 2, and 3. What's the range? Let's come up with let's do our table here, and the independent variable goes up top, so that's b. The dependent goes on the bottom, that's a, and then we can fill in our table. So our domain is 0, 1, 2, and 3. We need to find the range. We're going to do that by plugging those b values into our function. I'm going to write the function again. It is a equals, let me go back and find it, negative 4b, and it says plus 14. Okay, we're going to use that function. Again, we're going to plug and chug, what I call plug and chug, these 4 x or b values into this function, and then we'll come up with our a values, and then we can write our range. Okay, so let's start with 0. So we got a equals negative 4 times 0 plus 14. 14. Negative 4 times 0 is 0, plus 14 is 14. Keep going, find the a value when b is 1, so we'll have a equals negative 4 times 1 plus 14. Scroll up a little bit. Negative 4 times 1 is negative 4 plus 14. Negative 4 plus 14 is 10, so 10 goes underneath 1. Do the same thing with 2. A equals negative 4 times 2 plus 14. Negative 4 times 2 is negative 8 plus 14. Negative 8 plus 14 is, so I'll write this over here to the side, equals 6. So 6 goes there. And the last one, 3. Negative 4 times 3 plus 14. Negative 4 times 3 is negative 12 plus 14. That is 2. So 2 goes there. So we've got our table filled in. These dependent variables, these outputs, those are the range. So let's write our formal answer here. Range is 2, 6, 10, and 14.